Добрый день, дорогие друзья! Мы очень рады вас приветствовать на прямом
Greetings, dear
эфире на
friends.
канале
We are
АЛЛАТРА
happy
ТВ.
to see you at
Сегодня
the
мы
live broadcast on the
общаемся с
ALLATRA
прекрасным
TV channel.
человеком,
Today
ученым
we'll talk to a
Сергеем
wonderful
Тулбашевым,
person, a
доктором
scientist, Sergey
физико-математических
Tulbashev.
наук,
He's Doctor
главным
of
научным
Physics and
сотрудником
Mathematics,
Пушкинской
Chief Research
радиоастрономической
Assistant of
обсерватории,
Pushchino Radio Astronomy
Астрокосмического центра
Observatory,
Физического
Director
института
of
имени
the
Лебедева
Analytics Project
Российской академии
of
наук.
the Astrophysical Center
Здравствуйте, Сергей.
named after Lebedev of the Russian Academy of Sciences. Greetings, Sergey.
Здравствуйте.
Мы очень рады, что мы с вами встретились в нашей онлайн-встрече
We are
сегодня.
very happy to
И
see you
также с
at our
нами
online meeting,
сегодня в эфире
and also with us
участники
today
международного
we have
общественного движения
participants of
АЛЛАТРА
ALLATRA
Антонина
International Public Movement, Antonina
и Станислав.
and
Спасибо, рад вас
Svetlana
слышать.
and Stanislav.
Прямой эфир
Greetings.
сегодня переводится на 5 языков. На английский,
Our live
немецкий,
broadcast today is translated into 5 languages: English,
и
German,
переводы
French,
делают волонтеры международного
Spanish,
общественного движения
Ukrainian,
АЛЛАТРА.
and Roman, and the translation is done by the volunteers of ALLATRA International Public Movement, and we are happy to see all the viewers who joined our conversation. You can participate in discussions and leave questions to Sergey
Мы
Tulbashev.
очень благодарны
And the
Сергею,
commentary
что
section
согласился
under the
поучаствовать
video,
в
we will
нашей
ask Sergey
онлайн-встрече,
after the
поделиться
broadcast.
опытом, знаниями
We
из
thank
области
Sergey for participating in our
радиоастрономии.
meeting,
Сегодня конкретно мы поговорим на
for
темы
readiness to share his
космическая
knowledge in
погода
radio
и
astronomy.
изучение
And
пульсаров.
today we'll talk
И вот
about
первый вопрос.
space weather and studying
Как вы
pulsars.
пришли в
And the first question is
радиоастрономию
the
и какое
following.
было такое решение, что
How
вы действительно
did
решили
you come
заниматься
to the radio
распространением науки?
astronomy? How did you make decision to be involved in this field of science?
There are things that come in books and science and something that come by the odds. So that starting from age of 13, I wanted to be the astronomist. So I read through all of the books in the library, and I had an understanding of the decision that I have to make. When I started to enter, it was to the university, and it was not that easy. And my education was not enough to enter the university. This is why for 2 years I wasn't able to enter. Then I served in the army. Then for another year I prepared to enter the university. So I only entered for many years after I finished and graduated school. So speaking about the regularities and sciences, because astronomy is really big. So there's optical, there's radio, which is the gamma astronomy, and other type of astronomies that are present there. So you have to pick something up. Actually, on the third year of studies, we have the annual papers, and you just go in the labs, and I asked them, do you need a student to work for you? And they said, and radio astronomist said yes. After that, I've entered the Pushchino Radio Observatory, and I worked there for 30 years. Here in the picture, you can actually see two of our instruments, so that this filled with wires, and then the background, the classic telescope, like the first telescope that was built there on that time, it was the biggest telescope in the world. So right now it's one of the smallest telescopes, only 22 years in diameter. You know, the biggest one are under the ones that are movable, so rotatable, is 100 meters in diameter and not movable, or they have actually up to 500 meters. So that one of the antennas is actually up to the biggest radio telescope of the wires that you see, and it actually, the main results that we have, the biggest numbers of articles that we've published, are done based on the observation on that antenna.
During the first interview,
Thank you very much.
when we
This is very
get
interesting.
acquainted with each other, you said that you are studying pulsars and you study space weather. So we gathered some information which is available on the internet, and in short, a pulsar is a rotating neutron star which has a very strong magnetic field. We understand that if something has a magnetic field rotates, it emits continuously, and it emits not only in the visual wavelength, but also in the radio wavelength. So the second point is that we understand that if such a massive star as a neutron star is rotating, its rotation will be very stable. Those who know what a gyroscope is, they understand what I'm talking about. A neutron star has the mass of the sun, but its size are just over 100, over a few, some dozens kilometers. So we realized that the rotation of all pulsars are of different frequencies, and they differ from one another as footprints or fingerprints. So we would like you to enlarge our understanding in this direction, since you're working in this direction.
Yes, Pulsar is a massive rotating star, and it has characteristics that are usually mentioned characteristics, the rotation one, so that in one spin you have like an outburst. So this outburst can be in radio scale, in gamma scale, in optical or visible scale. But pulsar, they've been discovered in radio scales on the measurement scale. They have a few characteristics or main or basic characteristics. For example, the rotation period. And so the periods of pulsar and the biggest number of pulsars known was the high accuracy. So 1 up to 1 in a billion seconds. So that not 1 in a billion parts, in 1 in the 100 trillion portions of the second. So that even though the pulsars, you know, up to 2000s of those, on the period that they rotate or emit something, you can distinguish them from one another. The second part, so the impulse of the pulsar that is visible for us. Could you show the picture, the first picture? The picture that we see right now, it's actually, you can see this periodicity, or if we would get all the impulses together, then we'll see the mean profile or the mean value. So that it sort of like look alike, but the mean profile is actually, they have it different in every part. And the third characteristics is really important because in the space it's vacuum, right? And we've used to that from school, but really in the space it's not a vacuum, but a really not dense space. And this almost empty space, and if there any emission or impulse in the space, it transcends it with different speeds, so that the speed of light in this vast majority of space is a constant, but the different types are not, because when pulsar emits something, it comes in a different time and different wavelength, so that the impulse are just getting like diluted, sort of. Could we have the next picture? So on the picture number 2, you would be able to see, yes, it's that one, right? You can see actually here the big number of impulses from the top you have on the lower frequencies, and in the low part you can see the high frequencies one. Before to this pulsar, you see the distance of like 1,000 light years. The impulse went for 1,000 light years. It went for us for a big, vast distance. And in that period of time, it from the same frequencies, so that on the lower frequency part of that is behind the back, and the higher impulses came earlier, and this is how we can see through the media of the space, so that their impulses is really hard to find. So this is the example that I found for myself. If you would think that there is a vast like unsettled seas, and you can see that the wave amount of 12 meters, so that the wave appears in one another place, and we are being told, so like based on those irregular wave, there is an irregular process. The wave that has the same width happens to came either to the bridge or to the top of this wave, and the height of that is 2 millimeters. Could you find it? So the search for pulsars is sort of the same objective. It's really complicated technically, but it's supposed to have a big amount of expenditures. So in our observatory we found up to 70 in the latest years. But completely mentioning the pulsar, it's a completely developing field because we always find something new. We found pulsars that are called rotating radio transient parts. And their characteristic set is that they don't have periodic emission, so that they are pulsar but not periodic, so that they have impulses once a minute, once an hour, so that they have constant impulses or outbursts or outbreaks. We don't know not to where to look for them, and to find those objects are really complicated, so that the third of the discovered such projects, it's actually happened to be found in here. So you can see those outbreaks happening on this, so that the scale or the angle shows how far from us this pulsar is actually happened to be from us. So this is how it sort of goes.
Thank you very much. Thank you. It is very interesting. Could you please tell us, Sergey, what are the tasks for you while studying pulsars, and what is interesting about pulsars for the astronomers?
So that first it was just like a sport. Like in the sport, it's really hard to find one. And my background was this, I can say that astronomist, an observer, so the experimentator. So it's a complicated task so that we found to be in the place where we had our telescope actually in a good state. We can finally do complicated tasks using them. If you would say mention pulsars, in the first place, the pulsar is an object, astrophysical, with the extreme values. Density, 100 million tons in the cubic centimeters on the surface, and the center 10 times higher. What is 100 million tons in the cubic centimeters? So that's cubic centimeters, which is we would be able to conduct to water. So this water in 1 cubic centimeter that is placed, they would take a lake kilometer by kilometer and in a big depth. So this is either like this tray of water that would get to the moon from us. It's it's actually emits and lets to get the electricity from one place to another, and it's a superconductor. It would be a wonderful superconductor if we would be able to use so. And it's actually they have the superconductivity in the billion degrees Celsius in the center of the pulsar. They have a giant magnetic field, so that in Earth has 1 Gauss. The typical pulsar's field is up to trillion of Gauss, which is a measurement of the field. But the numbers are really great, so they rotate really fast. They have up to 700 rotation in a second, so that the object with extreme values. So it's really easy to check on them. Many theories that are similar to general relativity theory, so that the Mother Nature has given us the instrument that we can use to. So that it's like the lab in the space, and you won't be able to create such a lab on Earth. This is why pulsars are really interesting. So among the objectives that are actually can be of the screaming one sort of for you. This is the search for pulsars and the Andromeda Nebula, or the closest galaxy that we have. We really hope that in the nearest 3 months we'll be able to get some results.
I would like to come back to the topic of the pulsars we mentioned during the first meeting. Could you please tell us more about this topic?
Right. On Earth we've used to, so like if you're saying that the navigation is more of the specific types of equipment that you need, astronomic ones, then you can actually define the widths and the longevity and So that because of that, we were able to have the satellites in the space. So we have GPS or global positioning system. We have the same system in Russia, GLONASS, and Galileo in Europe. So the same system in China. So that there's 4 different geolocation systems. It was done for military systems, but it appeared that for the public life, it was really a useful tool. This is how on Earth we can have the coordinates up to 10 centimeters. So that for the public usage it's up to 10, so up to a meter, but for the military ones it's up to centimeters or something. So all those satellites are only are related to Earth and can give you the coordinates related to our planet. So what do you do in space? Usually a space mechanist can actually do so. You know how you launch the rocket, you know where you launch the rocket, and you have the engines that can actually do some minor maneuvers. So you said we've launched, but then space mechanist where it will actually get to. So this is slight unprecision or inaccuracy in the launch. You will have to do corrections, and if you're flying far away, then you don't have any coordinates actually. Then we've started to develop a system that would allow us to have the coordinates, the system in this coordinate space in the cosmos. So the point of the system is really simple. If we have the ant signal of the speed of light, no matter where the spaceship would be if it given the signal, and we know the time where it given us, so then we know the distance to it. So the speed to that, it's actually known. So you need to know just specifically where it's located. But we know there are pulsars and they have a periodicity. This period is known as with the high accuracy. When this spaceship is moving, it moves relative to them with the speed, so you have a Doppler's effect. So that you have a measurable period, a difference from the period that is real from them. If we have a few pulsars between them, you just make a network and you try to you have to make a point in space where you're located. So it's like 100 kilometers or 100,000 kilometers in the framework of our solar system. So it's developed, but when it will be used, not all we have to have all the countries on board, and because other countries has actually removed everything that was concerning deep space, separate experiments, and there's just really lacking in them. So that will the system work or not, it's really not known to us right now.
Thank you very much. When we were preparing for the topic of pulsars, we found such information in the book *ALLATRA* by Anastasia Novych that in 1054, the year 1054, there was a supernova explosion, and the pulsar emerged in the center of the Crab Nebula. It occupies about 25 kilometers, and it actually feeds the entire Crab Nebula, and it emits light like a beacon. Now, what is observed by scientists, they observe very powerful outbursts of light from this pulsar. Also, there is an interesting piece of information in the work by Nikolai Shakura about neutron stars and black holes in the binaries of stellar systems. And we have a couple of questions which we would like to ask you. The first one is simple. Why pulsars are compared to a beacon? And what is this beacon? What does this serve? And what way does it show? Maybe you can comment and tell us more about that, maybe from some philosophical point of view.
Maybe for the viewers, so the White House is just like something that was built or created, crafted by alien civilization, shows us the way to somewhere. So that if philosophically speaking, reality speaking, we know that the lighthouses is the periodically emitting objects that gives us characteristic that allows us to navigate somewhere. So the pulsar is sort of the same thing. So it lights up and it gives light by a unique way. Every pulsar is unique and you can navigate actually out there. So that actually it's a wonderful word to use, but it's not an accurate one.
It's quite interesting that we are talking a lot about pulsars, but we haven't actually talked what a pulsar is. A pulsar is one of the variants of its origination is explosion of a neutron star. So this mentioning about the lighthouse, since this massive object has a immense gravitation and magnet field, then it can emit from the poles. Since it moves around in space, when this pole is directed towards us, really emits these poles. That is why it's considered as a lighthouse. Is that correct?
You need to actually clarify here, not when it moves towards us, but the thing is the Earth also has, so that we have the pole of the movement that we have, and we have the magnet actually part. So in many stars, the same case, and the pulsar has the same specifics, so that the magnetic pole is really far away from the actual physical pole. So then when the pulsar is actually moving, so it creates the worm or the spiral in the space. So if we are at the actual end of that spiral, we can see this outburst or outbreak there.
So you mean this emission of pulsar, right? Yes. When you say about the pulsar, if you consider it from this point, we
So
can see like separate.
if you would actually see it with the short intervals of time, and you will try to get a higher time resolution. So this impulse is actually could be break down to many different other impulses. And if you look for this microstructure, you can also see even shorter intervals of impulses, and it can be breaking down. So the shortest outbreaks that are known to us right now, they have half a millisecond, so that less than 1 billion part of the second can be the smallest outbreaks. And how those impulses or outbreaks is actually formed, that we don't have any ideas from the theoreticists. So that we have the problems of giant impulses as well, because they are present in many pulsars, but why are they appearing? And how are they appearing?
And what do you mean that it really gives power to the Crab Nebula? As we understand it, that it has an immense mass and stretches it around it. Do we understand it right?
It's not actually like that, because what we see here on the nebula, what happened was after the explosion of the nova. So that because of that explosion, the leftovers of neutron stars actually was dispersed. So this matter actually been flowing out of the space, and that there's more and more space in this space or the cosmos, and they don't have its own membrane. Oh, the energy that was there, and it was the energy of the pulsar. So the membrane or layer, it would sort of somewhere, and so it was eliminating light because it was hot, and then they actually will get dark because they don't have an energy. So the pulsar is actually adding energy because of its emission and impulses. You have the additional energy source, and this is why this outside is actually luminous light. So you have different emission or diapason. So this, you can see that there's different objects, because in different ranges it looks completely different. So the pulsar will disappear or stop actually illuminating light. The membrane, or what you can see, is actually will disappear as well.
I see, I understand. All right, so we're talking about different ranges. What we have learned in literature, the young pulsars actually emit in visual range, and as pulsar grows older, it begins to rotate slower, and the visible light is no longer emitted. So it begins to emit in the radio spectrum. So pulsars, this is for our viewers more, they emit in the radio wavelength. So that is why we are speaking about different spectrums, and that they can be observed in different ranges.
The biggest number of pulsars are known in the radio range, or part of the spectrum. So the radio is the least energetic one. So the energy that is in the radio range is really minuscule. Just to compare, the pulsar, for example, in 1 Yansky, which is the regular unit, It's meaning it's a strong pulsar. What is one Yansky? One Yansky, so there's two different exchanges or different phrases. One out of 100 million, out of 100 billion of 100 watts. Watt is what you have in your batteries. This energy is strong, right? So like, if you would say with our regular language, it's 10 in the minus 26 degrees. So that even though the energy from a pulsar in radio range is really small, the biggest number of pulsar can be visible in radio range because it's easy to generate this small energy. The optical range pulsar are really low in number, and the X-ray as well range is also lower numbers. So they emit something because of different mechanisms. It's not because the magnetic sphere is moving. So the X-ray pulsar, they emit something because on the surface of the pulsar they have some matter, and because of the collision of the matter with pulsar, it emits X-ray quants of the X-ray. So this are different mechanisms of the emission.
By the way, what is more curious about this, what we have found, is that X-ray pulsars are at times a part of binary systems, stellar systems. So we have already mentioned that due to the collision of matter that comes to the surface of this pulsar, we have this emission. So we understand more how this emission actually, or the mechanism actually of emission works. So I would like to come back to the topic of our program, and we know that recently scientists observe a very strong magnetic field and X-ray emissions coming from the Crab Nebula. Can you explain or elaborate about this?
This pulsar, from time to time, they have the increase in X-ray or gamma range of emission. The reasons for that, it's like a part of accretion. The accretion is the collision of the matter on the surface of the pulsar, where this matter came from and for how long will it happen actually. Independently, the gamma range of the emissions is really high energy ones. At the end of the day, the general energy that comes from this pulsar is really low. So that from us, it's not like dangerous in any way possible, but when it will stop, it's actually not really clear to us at this moment of time. But there's nothing specific where many pulsar actually emits in gamma range, and then they actually appear, and they can actually go away again.
Thank you.
Thank you very much. And today we also talked a little bit about navigation. You know that pulsars give an opportunity to produce a scale time, to make a time scale. And since navigation uses atomic clock nowadays, by which they orient themselves, which is very important, will there be any time scale which will enable us to be oriented to the pulsars more accurately?
Regarding the time scale, it's a really complicated one because we've got used to, or we have the feeling that time is equal everywhere. We don't know that really. In the framework of Earth, we've measured it. In the framework of the solar system, we did third of the time is flies with the same speed or something, but can we be sure or certain that near the center of the galaxy the time flies the same intervals that we have it, or in some faraway galaxy till the end of the universe? We don't know that actually. This is why any additional time scale, it gives us a new stage of freedom actually. As an example, we can mention next time, we are sort of constant thing, and we can say that we can give an example, the distance as the standard candle, for example, which is like supernova different types. In a moment of the top brightness always emits the same amount of energy, so that no matter where the supernova be, no matter in what galaxy it is, if we've proven that this is a supernova of that type, we know the precise or accurate distance to this galaxy. From the other point of view, many viewers do know that there's the red diffusions. The farther the galaxy is, the faster it moves. So that if you've measured the red diffusion, you can actually define the distance to that. But you have somewhere the supernova outbreak, so that you define it with two different ways. one for the standardized like candle and another one by the red actual emission. So this distance is supposed to be in light. So this is the experiment that was conducted before, and they found out that the further the galaxy are, the bigger the difference between the regular candle and the redshift that they have. For that, the Nobel Prize was won actually by the dark energy breakthrough, because we've just measured with the distance with the two different ways to do so, and we found and we got ourselves a Nobel Prize. Could you imagine that with the scale of time? It's sort of like that as well. It's always a when we have a scale of time, a working one is really different because we have to conduct a long-term observation of the pulsar. How can you do so? On the short interval for an hour, you do so, and the pulsar, it's you see 300,000 impulses. So I would measure it or something, and so the period is 1 second. So that in one day, the peak of the impulse would go in that way. You actually measure it, and it's not there anymore. So maybe it was in the second, but 0.9999 of something. So that you've clarified your period or something, but in 10 days you look at that, but it's still not there. And so that you can, with those changes, calculate the correct period of emissions. So if you have many pulsars that you know the correct period of pulsing, you can create a time scale just by looking whether its emission is actually hitting the right period of time of your observation period. If it gets there, you can say, yes, I have this time scale that is independent from the time scale that is on Earth. So they are connected, but if just in case they will get in different places, you will feel it and you will notice it.
Thank you very much. And also today we wanted to ask you about another field to deal with, it's space weather. We know what weather outside is, but what is the space weather? How does it influence our life, climate? Could you please tell us about this more?
So that the space weather is just like the weather of the star, or that we have the sun that we have, the amount of energy the sun gives us. It's varies in the big differences. So that from day to day, from year to year, this differences in the amount of energies that we get, it's like up to 0 point something percent. But if we would speak to you about the outbreaks that we have on the sun, so the corona mass outbreak, so the energy inside of this outbreak, it's even lower. It's a number lower, because the comparing to the overall energy of the sun, this is the minuscule values. But if you would to this outbreak of the corona mass would hit to or get in the direction of Earth, then what we have is that Earth has been hit by the cloud, or frequently or fastly with high velocity moving particles of plasma, and it actually involves with the one of the spheres of the planet, and also actually acts on the space station that we have or something else that we have. Unfortunately, it can get to the okay, so what can happen is that it can disperse the satellites if they have turned on the electricity. You have to turn them off before that. If we are speaking about what we have on Earth, then it's the general fall of the magnetic field on Earth, and most of what we see that it's on the poles of Earth. It can actually be acting on any type of the tubes or any types of wires and transformators, so that the harm from such an even small outbreak, it can be greatly done, but if you cannot prevent it some way, so that we need to actually do something for that, and we need to predict when it happens, so that those kind of observations are actually happening in our observatory.
I also would like to clarify, inside right now, much depends, the space weather a lot depends on the solar activity, and can we say that the sun determines the weather on Earth, or is this not correct?
This is correct. So but in relatively, so those outbreaks of corona mass are not influencing the climate, so it's not enough in energy, so that the general climate it doesn't really influence. They look at the influence on people, so like the how well do you feel yourself, but really I'm a big skepticist in that way because I think it's not supposed to influence them, because the general and overall energy that happens to reach Earth is not that big. It's really maybe it can influence cell phones or something. From the cell phones we get so much more harm than from the outbreaks on the sun or of corona mass. So that I don't think it acts that much on the climate, but just study of the sun, of the activities on the sun, yes, it's important because there are periods of when there was like ice caps or the ice period when it was too hot on Earth, but it's connected to the fact that CO2 have in the atmosphere and other things that are present that are indirectly connected to the sun, actually.
Thank you very much. I would like to clarify regarding the cycles, solar cycles. So we know that these cycles influence the climate on Earth. And can you please tell about that? And also, when there is the minimal point on the sun, how does the space environment change? I mean, if there is less, the minimum radiation from the sun, how the environment around it changes, and maybe the galaxy radiation changes.
We have a stronger actually the galactic, any type of impulses or anything that is there in the mission of the galaxy does not actually influence us to us. But if you're saying about the cycles that the sun has 20 years or something on Earth, in our observation it shows in that way. The sun wind is actually usually sticks to the equator, so that it takes much less space. This is the minimum of the activity of the sun. There's not a lot of dots on the sun, so that the sun wind is just like around the equator. When there is a top activity, sun wind actually hits all of the solar system, so it's equal throughout the whole solar system. So in the both cases, we found it out in our observation correctly in the difference of the impulses or the light that we have. Maybe in the next picture you can show it, which is the picture number 4. Right, so you can see here in the picture different days, so that the first and the second and the like in different timetables. So that the first you have the arch, like the red arch. This is the increase in the like the blinking of the sun, so that the increase in that moment of time there is an outbreak or the outburst of the corona mass. Out of the few days, those outbreaks have actually moved, so that it moved. Those red dots have moved. So the third or the first day, you can see the scale that it hit Earth. So like, but the Earth is everything okay. So those kind of pictures, they're not really like the specialists understand when they see picture like that, but for people they don't really see much, show much. But it shows actually the strength of the scintillation on the star.
Thank you very much.
Thank you. We actually have already mentioned about BSA, the big scanning antenna. We know that it hasn't been used in its full potential, but we are able to study the space weather with it. So we would like to know about perspective of this direction in science.
How can you actually track the outbreak on the sun? It actually looks like an X-ray outbreak, but if we see the X-ray outbreak using an X-ray telescope, then you can see that when will it hit Earth, and it depends on the velocity of that, and unfortunately it doesn't define. So you can track it in X-ray, but then you need to get to know in what moment of time that it will actually hit Earth. Then we have this method that we use, the method of scintillation, and it can actually track it up to 7 to 8 astronomical units. And if you track that, you know the velocity, and there are also satellites that are in the Lagrange spots, which is the 100,000 kilometers from Earth, and they just fix the walkthrough of this outburst through the satellites. And it is known like that if it's happened there, then in 20 minutes it will be on Earth. So that's not you working alone. It's not the whole chain of the event. So there is like 3 stages. The chain is actually longer. And only joint efforts will allow you to answer this question. So what happens is that for our telescope, it can track the space weather, but usually we get it all together. So everybody who takes care of selection systems, so that it's stationed big, so that we have those stationed in Japan, India, Russia, Mexico, Europe, Australia, and in the USA as well. And I think that there is also in UR, and we are trying to control all of that, so that there is an academic part and there's practical sciences, because the cosmos weather, it's an actually practical science, and it requires an additional funding, additional adding, because we are in the academic facility. We're being paid for article, which is say we're being paid for publishing articles. We're supposed to conduct an amount of scientific work, and that amount of work is technical, because the science has ended like 50 years ago, because they 50 years ago knew how to do so. But just to bring to the place where you can actually open, so that just to make it to turn the TV on and say that the cosmos weather right now is that state.
Great, excellent. Sergey, could you please tell us, there is another question. What discoveries could overturn our idea of the universe, of how everything is structured, about life in space? What can change our worldview, actually, universal view?
I think any astrophysicist, any scientist, and actually every person on Earth has this answer. So I could speak about it as a private person. So it seems to me that such discoveries might be, there are actually three of connected between each other discoveries. So extraterrestrial civilizations, this prove that we are not alone in the universe. That would completely change our way of thinking. Another, it's also connected with the mind, the ability to live infinitely. So are we as people, our personality develop infinitely? Can we reach personal immortality? It seems to me that it's a very crucial point and temporal point. So when speaking about literature, I find it that it's possible. So, and the third one is creation of artificial intelligence or artificial consciousness. So when we read books or we hear other people saying about this, there could be some perception that there is some kind of intellect, artificial one, that can pass Turing tests. I would really like to believe that artificial consciousness is possible. So these are three blocks that are connected with each other. And the second block is just related to astronomy. The proof about multi-dimensionality of the universe. So we actually progress and develop with a very immense speed. We actually should have already discovered extraterrestrial civilization, but we had not. So where are they? Well, suppose we are alone in the universe. So we are developing, we have mastered immense energies, and what's then? And we have vanished as humanity. So the transition towards other universes actually tries to postpone this issue of our mortality. So this is a crucial point, as I believe.
Yeah, very interesting. And in addition, I'd like to mention that in ALLATRA book, there is also the concept of the immortality of personality, and participants of the ALLATRA International Public Movement created a new project which is called XP Energy, and it is related to creation of artificial consciousness, which is a little bit different, but we have a presentation of this project on our TV channel. I think for you, for other viewers, this will be very interesting, because it opens up new trends in
Actually, this speaks that the thoughts of many people are actually directed into one thing.
Yes, unified information
Да, еще
field.
такой хотели задать вопрос касательно, какие открытия
We
в
also
радиоастрономии
want
могли бы дать
to
мощный
ask
толчок
you the
для развития
question which
смежных наук,
discoveries in
квантовой физики,
radio
ядерной
astronomy
физики,
could
химии,
give an
биологии и других
impetus for
наук.
the development of discoveries in other fields like science, physics, chemistry,
Well,
quantum physics.
speaking about astronomy and physics, is something related to light speed, for example, very high-speed moving objects. So these are the sources, infinite sources of energy, because everything around it is defined by energy. And by the way, as an example, we have in the last year we had the director of the Cosmic Center had really a lot of discoveries, and in particular he was searching or studying the extraterrestrial life. So he was classifying it in the light, and civilizations like weak ones like Earth, they have the energy that or the amount of energy that the sun actually radiates towards the sun. So if we master this kind of energy, so 1 square kilometer multiplied by 1 kilowatt, then even we have not grown to this far, but still, those who master this kind of energy of the star that is nearby, so that's when they become this the second so-called civilization. This third type civilization is the civilization that have mastered the energy of the entire galaxy where they live. So in our galaxy there is 1 billion stars, so if we have mastered this kind of energy, then we will be at the third type civilization. So the energy power consumption really defines everything of power generation, but how astronomers can give the impetus towards mastering these new types of energies, this is quite an academic issue, and I don't know really how it will be solved and when.
Спасибо большое. И мы так интересовались и знаем, что сегодня впервые
Thank you
те
very
данные,
much.
которые
And
и
we
те
also
разработки,
got
которые
interested,
впервые
and we
были
know that today the
использованы
data
в
and the
радиоастрономии,
inventions which are
радиоастрономом,
used
используются нами
in
сегодня
radio
в каждом
astronomy,
дне.
it is
Не могли бы
basically
вы привести
used in
примеры
our
такие,
everyday life.
что мы
So
сегодня
could you
используем, то,
give
что
such
впервые было использовано
examples?
радиоастрономом?
What kind of technologies we use, which were the first used in radio astronomy?
Okay, let's not talk about just radio astronomers, but astronomers as a whole, because radio astronomers are just a little part of the whole direction in the science. So it means that I'm just in some kind of observatory and I'm studying the radio signals of the stars. So the astronomers actually developed the service of time. There were some standards like atom standards and so on. They were needed for practical discoveries, practical research. So eventually it became to studying the celestial mechanics, to GPSs, and the basis of all their programs is what is related to celestial mechanics. So that's what we use every day. Another example, there are a lot of discoveries made by astronomers that were used in like programming and for example in computer tomography systems or image recognition and so on. So these are not just academic scientists, but they actually gave an impetus toward everyone, every field of science. So once they were just astronomical discoveries that lied within these discoveries.
Thank you very much. There is another question, but basically, Sergey, you have already answered it partially. How the knowledge astronomy, radio astronomy influences formation of people's worldview. But maybe you'd like to add something to that, or we can proceed to other questions. If you'd like, you can add something. Basically, you already talked about when you were talking about discoveries.
I would like to give just a little more example. So if we could see this graph, So academic science actually gets involved with things that will need maybe in 10 years and 100 years, and maybe we'll never need it. Then the saddest thing is we don't even know the right direction of development. And this leads to the fact that the knowledge that are exponentially enlarged. And at the same time, these knowledge are really becoming more difficult to cognize, to understand, and to learn everything. So this graph shows how the pulsar astronomy was developed. So there was Peter Wilkinson. We have a link about this. So there are many articles and there are many links to these articles. So these are like philosophical and basic things. So we have discovered that 100 pulsars, for example, and we have discovered another object, or another phenomenon, and we have discovered 400 of them. So this function shows that we have a very rapid growth. So in order to make the next discovery, we need to discover 3,400 objects. So this means we don't even know how to develop science as a whole. And unfortunately, as of now, both in our country and abroad, actually government dictates how science should develop. So we actually start to study what is already known. So there is a term known knowns, known unknowns and unknown unknowns. So unknown unknowns is what actually science actually is engaged with. So meanwhile, like during my days, you had to make an application, and in this application you should actually include what's the result you will get. But if you know already the result, then what do you need this discovery for? So science should be either in the field of known unknowns or unknown unknowns. So these are fields when you conduct experiments which could really lead to new shifts in discovery and in development of humankind. So one of the latest things is the discovery of dark energy. This is unknown unknowns. No one actually expected that just was an experiment and of one thing, but they discovered the other. So another example is gravitational fields discovery. Everyone knew that they were, but no one could actually discover them. And it took quite a lot of experiments to discover them. So academic science actually starts going towards a direction that is not needed, that is obvious. But at the same time, with the amount of knowledge we have nowadays, that one person cannot even run his head around this knowledge. So this is unachievable.
Thank you very much, Sergey. And I would like to summarize. We can see that scientists do a lot for each of us, for the entire society. And this is a fact. And the examples you've given is a confirmation of that. And in addition, we know that sciences really expand our worldview. They form it and they make a basis for the further development of science, not so that it doesn't stand still, but it moves on. And on the platform of ALLATRA International Public Movement, we have now we have social surveys around the world within the framework of creative society. And the question is, what kind of society we would like to live? We would like to say that in the creative format of society, people will choose themselves what trend of development of science will be. And the society will create the best conditions for the science to be developed. And yes, for developing for people, it will be a creative, constructive, and peaceful science. And scientists will be happy with what they are doing. So with respect to that, I have a question. What kind of society would you feel yourself happy? And what kind of society would be comfortable for you and your relatives and friends to live?
Generally speaking, I actually love to read books a lot, and in my childhood, these were books of Yefremov and Brother Strugatsky. So naturally it's a communist kind of society. Since then, I have changed a lot, but actually, I became a lot of skeptic about what relates to communism. The thing is that in communism, there was the main motto that everyone should have, should give from what he can do and get what he can achieve. But so you can do the maximum, but the society should only give you an opportunity to do this work. But at the same time, every person can do everything what he's interested in and gain a lot of satisfaction from this. It can be discovering some making discoveries in science or developing technologies. So human labor of, for example, those people who work in mines or shop sellers in the shop or bank employees actually could be shifted to artificial intelligence. And so we will have a lot of people who are free from work. So that could be quite a good possibility. With minimal expenses, you could actually improve your life dramatically, and you could develop intellectually and ethically. So experience shows that as society becomes richer, there is a greater disbalance in this society. This is not right, but I don't see how it can be otherwise. So that means that this motto, when everyone can do what he can, is actually implemented, cannot be implemented in this society. So this is the society I would like to live in. I know how it should work, but I don't know how it comes to life.
Yes, exactly. Latra International Public Movement exactly unites all people who want to change themselves for the better and who want to change the world. And I would also like to add and ask you, what is your vision of science in such a society? Let's just imagine that we don't have any problems anymore, which we can talk about now, like financial problems, and we can develop science in the way we like, in a way which how we feel and how our soul requires it. Yes. How would you describe such a scientific trend in general or in particular? How would you envisage the development of
Speaking about the science and about technical things, actually everything here is quite expensive. So if we assume that we don't have any problems about funds and you can spend like on anything, then firstly that would be exploration of planets in solar system. And this is right, because if we have some cataclysm, then we should have like a spare planet to live on. So if we speak about technology, then it seems to me that as of today, we still do not have any grounds about how it should develop, really, because what we see in reality is quite far from what we wanted. Surely, I would want like new tools, new instruments, free labor, free trips, communication with people around you, and solving problems like big problems in science, so that we could actually concentrate on solving them. Unfortunately, there is nothing like this in scientific society nowadays, because we have spread too much in the direction. So I don't have a recipe or understanding about this, but actually, if we just speak about people in general or work in general, not just about science of a good society, then speaking about Yuri Nikulin's words, I think it's his words, that when you are happy to go to work and you're happy to return home from work. So this is a good society. And
Thank you very much.
We have also another question, so that we all understand right now that science has funding, right? And so if this area is being funded, then it's been developed. If it's not funded, it's not being developed. If your uh, activity would not be defended funding, what would you do? What would you be taking care of? Where would you actually input all your time and attention?
Well, many writers, many authors have, like, say, what's your favorite book? The one I'm writing now. Because when you start getting involved with some issue or problem, then you delve deep into it and you see that there is nothing more interesting than this. So now I'm involved in studying pulsars and transients about phased radio bursts, and this is very interesting for me right now. So tomorrow could be something different, and I don't really know what it depends on. But at first, I would like to stop with one problem, but and go to another, because our life is quite fleeting. During the life we can actually achieve just very few big tasks, maybe 3 or 5. So I started working with pulsars, studying pulsars since 2015 maybe. So, and I only see something about the horizon, but not after that. So I have a notebook at work. When I'm studying, when I'm reading some articles, I'm writing there and writing the ideas about this and providing the link. So, and I have about 300 tasks. And during a year, I could do like 1, 2, 3, maybe 5 articles. So I don't know how many of them I will be able to accomplish during my lifetime.
This is incredible that you have so many ideas and inventions. I hope that in the format of creative society, you'll be able to accomplish. And also we have another question. Perhaps there is some idea from your side. Maybe it's a little idea so far, but what can we already do now so that such a society would already become a reality? Is it possible to do at least?
Actually, every person is really responsible for about himself. So if you're responsible about yourself and you say that I would like to live in a society where people are kind and sincere, then you should be kind and sincere. Therefore, it turns out that in order for this society to emerge, we really need, or people need to be responsible and to have a certain response for the society. So if you would like to live in a good society and if you're involved in thieving or killing, then how it can be true? So how you should not belong to the society, the castaway, and how? So I realized that there should be some kind of ideology or education. So unfortunately now in Russia, in our country, this ideology is getting scarce or a little sideways, because it's far from communist ideas. But as for me, I'm an introvert as a person, and I actually lock myself in the house. So I have a lot of books in the house, and I have a loving wife and the children and friends. So this is enough for me. So I have arranged my society about people I love and care about. I don't really get involved in dealing with the whole society, because if you make one person happy, then the society of the whole world becomes a little happier too. So be responsible about yourself.
Thank you very much. So we should start with ourselves. Yes, thank you. And also we have many questions from our viewers. It's so joyful. Thank you very much for your questions, dear friends. The first question is the following. It relates to the holes. Will these wormholes help to overcome not just space, time, but also space? What do you actually know nowadays about wormholes?
Some time ago, when I was studying university, and it was like 30 years ago, there was a program called Machine of Time, and the lecturer was Igor Dmitrievich Berenkov, and he wrote a lot of popular books. And as students, we actually came to him with questions how to arrange this kind of machine of of time. So he said that, yeah, there's a wormhole and it connects to the certain point in time in the past, and he showed us this in pictures. So, but how? There's a paradox. If you actually found yourself in the past, or you just killed your grandmother, well, it's a crude example, but still, so something that led to the fact that you were not born. So how's then? How can it be in this case? Can a wormhole and machine of time really exist in this case? Because this is a violation of singularity. Why should you kill your grandmother? Well, why? Because we have a freedom of will and we can do what we want. So, but now we are in this auditorium, in this room. Would you like to fly? Well, yeah, but we don't have wings, we have gravity, and we started to explain why we can do this. But in short, so the laws of physics are so that we can do that. But do you know all the laws of physics? So can it be so that there are some laws of physics that actually limit our past from us, although you can actually go there? With wormholes, it's likewise. So this is a theoretical object. Wormholes, in order for it to exist, as I understand it, there should be some certain particles that are not really discovered and no one knows really if they exist. So these particles are written about, but no one discovered them in any experiments. So again, these are just theories. In practice, we haven't even approached it. But one of the tasks was, the magnetron would be launched soon, and one of the tasks of it is to search for wormholes. So this is a technical assignment. So whether it will find it or not, we don't know, but it's a technical task already.
Thank you very much. The next question following is that can an amateur in radio astronomy help a radio astronomy professional?
We actually tried this a lot. So here's the thing. The thing is that the tasks, when we studied, for example, at school, so we have certain tasks. So we sat there and thought about it. We have a day for this task and so on. But our tasks actually mean that we'll have like many work hours for it. So this is not just a nice picture of space that we took. These are like immense, huge time span. So there are already known like methodologies and articles, and my son, for example, is a programmer. So he actually spent 2 years for writing the program for me. But then I actually tried to understand how much time should I need in order for this program to work. And it turns out that it took me 1 million pictures to look through with my eyes to get the pattern, and so that I will be able to provide the technical data for the program. So usually they say that to calculate something, but in order to calculate something, we need to write something. We need to develop a program, to write a program. So, and these programs are coded by people. So there are some people, I had that, we could write something or we could solve some simple task. But what is a simple task? Is a month of work. So it's, leaving the work, So the person sets their programming and still, there's no enthusiasm because he spends quite a lot of time for developing this task or this program. So people leave. So just because we don't have simple tasks, quick ones, like using a calculator to calculate something. So unfortunately, everything is quite lengthy.
Thank you very much. The next question: what is interesting and important about exoplanets? Why is this topic very paid so much attention to, and does it relate to climate?
The interest towards exoplanets, from the old age, like 16th or 17th century, so they believe that Earth is the center of the solar system, or the solar system is the center of the galaxy, and so on. But now we realize it's developing, that the Earth actually rotates around the sun. So there is a theory that there should be living organisms on different planets. So when this issue arose, we actually started to find the opportunity to answer this question, and this task is as immense as finding pulsars, or even technically more complex than this. So exoplanets are being found just to prove that we are not alone in the universe. So the exoplanets are found, then the next generation probably could find out if there is life on these planets, and it's not from sentient life about this.
Yes, thank you very much. And the next question is, are pulsars dangerous for the Earth?
The pulsars themselves are quite far, not quite far, so 300, 400 light years from us. This is quite far. But the thing is that the explosion of the pulsars is what's dangerous, because but such stars which are able to, like supernovas, like supermasses, they are not near us. There are some, like two dwarfs which have this matter of accretion, and they can explode too, and they can cause problems, and they can be nearby, but so there is no harm from pulsars, but supernovas can cause a lot of problems.
Спасибо огромное. И вот как раз следующий вопрос касается звезды Бетельгейзе.
Thank you very much. And the next question exactly relates to the Betelgeuse star. It's one of the brightest, and it can turn into supernova faster than it was expected. Can it explode due to its own gravitation? If such explosion happens, does this threaten the Earth and other close adjacent objects in space?
For the close or in proximity to that star, this is the big star. They're probably just gonna vanish, or just gonna fly away somewhere far from the star. For us, that would be harmful if it would be nearby. So the distance to Betelgeuse is just a big and vast difference. So even with the vast explosion, we will see it as a really bright outbreak. It probably will be brighter than Moon, but still, because of the energy is proportion to the square of space and distance, so that we will only be witnesses of a small portion of those energies, so we won't have a lot of harm from that. Also, there is a moment you need to know that when, for example, the explosion will actually happen, we don't know with high accuracy to predict when the explosion will happen. It's sort of like, and it's possible it will be 1,000 years or 5,000 years. There's like no joke or no saying that there's an excursion, and that they're saying, so like the sun will explode soon in 3 billion years, and it will become a red giant. Can we ask you a question? Yes, you can. You said it will explode, but when it will be a red giant? In 3 billion years? I've heard like 3 million, and I got scared because it was 3 billion years. So it's the same thing. We don't know it, right? Like how accurate it will be. It's in the state when it can explode, but when it will happen, it has such a big unpredictability. It's the same thing as in Betelgeuse. It's not actually be harmful to us. The biggest pessimist that we have, that the explosion can be directed if they have this magnetic pole or something, and then there's a lot of energy is being thrown at one area. So the biggest pessimists are saying that it is possible that in this stage of a few hundred of light years, there can actually happen to be harmful. But Betelgeuse, even for such a pessimist, is still too far away for that to happen.
Thank you so much. And the next question is, what type of space rays is coming from a pulsar? What kind of energy does it emit?
The pulsar emits in most of the depth or ranges, but the most thing is the radio. It's also in the visible light and ultraviolet and gamma range as well. The best you can see it at
Спасибо
best
большое,
as in
следующий
radio
вопрос.
range.
Наблюдались ли
Thank you. And
закономерности
the
в
next
вспышках
question is,
пульсаров и их
have you
отражений на
ever
активности
observed
ядра
any
Земли и других
irregularities
планет
in
Солнечной
outbursts
системы?
of pulsars on the Earth or other planets of the solar system?
I haven't heard of the topic. I think it's not reflected in any way possible because we've shown you these impulses. It's really hard, but still, its energy is really minuscule. You can see that the overall energy is that the 10 in minus 20 second like stager. What comes first from a pulsar, it's really minuscule. But there's like an old saying that people came to a conference and like there was this like a table where there was a piece of paper like the turn over and read it. They were reading like by turning this paper you've spent much more energy than most of the telescopes would be able to record. If you're speaking of the radio, this really minuscule energy. If you're speaking about different ranges, there's more energy. But we can see stars; those are objects that emit a big amount of energy. But for us, it's like it doesn't harm us because we don't feel it. Because all those energies, they are harmful only in cases if there is like any explosive events, like supernova or just a nova explosion, or like asteroids or like comets or just big masses of bodies that could go through our solar system like in that case yes, but not just the simple emission. Those emissions are not influences I feel like in any way possible.
Thank you very, very much.
Все ли планеты нашей Солнечной
What else
системы
do
нам
we have?
известны? Могут ли
Are
быть
all
планеты
planets
за
of the
Солнцем?
solar system familiar? Can there be any planets beyond the sun, on the other side?
Maybe there is a twisted question. I can answer on how I understood it and on how I think that it's supposed to be. For how I understood it, from time to time, in the internet there is like rumors that behind the sun there is like a planet behind it, and we don't see it because it's always behind the sun. And so that we are in the sync, so that there's like either Nibiru or whatever the name is. So it influences everything that happens on Earth. First of all, we've had the satellites on the other side, and they haven't seen the planet. Even they didn't go there. The thing is there is this planet. If it would exist, they would see the changes in gravitation, which means that there is a planet. Then we would actually have the common place where we would have like the common space and any type of mass that's a big amount. We would be able to see it by the incorrectness of the movement of us. If this is the question of Nibiru, if the person who asked was understood correctly, if the planets outside of the Pluto, so meaning that there was the border of the solar system, we think that the Pluto is not a planet or planetoid, and the last planet is Neptune. If there is any further planets, yes, there's massive bodies that happen to be placed outside of Pluto with the mass of the Pluto. There's many bodies like that. Not all of them are discovered. They happens to be in the orbits far away from Pluto. Those distances are like the Copper's field, and they have other actually clouds or masses. And those planets also can be rotated in the same orbits and near the equator of the sun. So there's many of them actually. They have the mass of not in the big amount, but the outside looks like a planet, and we have many of them. Maybe we have like 15 or something. So I answered 2 questions. I don't know which one was correct, or still thank
Yes,
you.
probably that's right. And another question is the following. It's interesting whether Chizhevsky was studying the influence of solar outbursts impulses on people, and probably this relates to the point that Chizhevsky was studying how solar activity influences people, human beings, and physical condition.
From time to time in literature, we can see that there's they're looking for the correlation of this activity in the sun and what happens on the Earth, and they see the correlation, but I can say I'm really far from this area of the expertise because it's not really astronomical. It's more of It's the area that I don't know very well, so I'm not able to comment on that. I've read about Chizhevsky and the Kozyrev's works, but I don't have my own opinion on that. Sun is supposed to influence humans in somehow because it's really nearby and it's a star, and we exist because of that star, and there's supposed to be some kind of influence, but on how what's the depths of those effects, how can we feel them, I'm not able to comment on that. It's maybe more to biology or something.
This is probably closer to paleobiology.
Actually, I wanted to ask another question that in some sources we found that a pulsar is the Crag Nebula. It bursts in 2055th year, so about 1000 years ago. How it could be calculated, how it was discovered, because the time length is quite large. So the question is how it became known that it was exactly 1054.
When we've started to have the modern astronomy, so that it actually has the catalog number 1. So this nebula is visible very well. But why did it happen to be? Because the first the nebula, it was called a galaxy, and everything that we call right now a galaxy or a nebula. But when they found out that they have in the center a pulsar, we started to understand that this is the leftover supernova explosion, but it's a new one because this it actually happens to be nearby, and the nebula side is really the precise the borders. The borders are really the really accurate borders. And it happened to be that this object is really young, relatively speaking. The Chinese chronicles, there is a specific date that can be translated and says that on the sky you see the new star. And they have the coordinates actually where they was able to see it. The coordinates happen to be the same. The time was also the same. And the nebula is there. So they were able to find it. I'm not sure that was that, but still, in Europe, they didn't see any changes, even though the Chinese people were mentioned it because it was so bright that during a few weeks you can see it in the daylight, and that before it was brighter than the moon. And you can imagine that in Europe in that time that they have a new object. In none of the chronicles, there's no mentioning that this was called the Middle Ages. They wasn't interested in that. They weren't.
Thank you. Another question that I would like to ask this: the origin of the stars themselves. So, how the gas actually, or dust, space dust actually, starts this nuclear reactions, and what is the cause of the origin of star?
There is a complicated answer, which is a scientific one, but if you would simplify that, what happens is we have a lot of gas in something. We don't say that where it came from, so that this, if they would have like any borders of the big size, then the gravity is actually acting. The gravity will make this amount to shrink, and if you would shrink, and if you don't have the loss of the energy, then the particles that is inside there start to accelerate, so that the speed grows. And during the next compression, as soon as it's been compressed to an amount so that the energy in the middle, then they start to react. And so that what happens is natural process that is good with any bodies that compress. As long as the mass is bigger than something, that they don't have enough mass that so that the thermal reaction would start. So this would actually become the brown dwarfs. We have so many of them, so it's like not close to star. It's no longer a planet because the temperature on the surface would be from the thousands of degrees. So this is the really strong and hot objects, but it's still they only bring light because they continue to actually compress. But the Jupiter emits more energy than received from the sun. Why? Because they start to compress. The process itself, it's really being known, but there's so many nuances actually that why it's happening. You need to take into account the magnetic field, so the direction, and So that are we able to remove the energy excessive before the compression? Because when it's compressing more, because the energy of the particle will be so more that they won't be able to compress anymore. So there's a limit to that.
Спасибо.
Thank you.
Есть еще
Thank
вопрос
you
от
very
зрителей.
much. There
Многие
is also
звезды
another
двойные.
question from
Можно ли предположить, что и наша Солнечная система
double stars.
представляет из
Can we
себя,
estimate
тут,
that
наверное,
our solar
имеется в
system
виду,
is
что Солнце
also
тоже двойная звезда?
probably there is a mistake. Can we suppose or assume that the sun is also a double star?
If it's a binary system, that it has supposed to be a big star. So if our companion is a light year away, then we see a rounded joint like actual mass field, so that we don't actually spot this kind of movement. Then we are supposed to have an additional movement around the joint mass center, and then the second star. And so that the movement that we're not able to explain, but we are not registering this kind of movement. And if there is an any companion, it's supposed to be small, because if it would be big, then we would see just a bright star, just like a sun. We would see them right away. The closest star to us, it's almost 4 light years away from us. But the companion we don't see actually. Even so, that the biggest numbers of
Тут вот
galaxy
дополнение
we
я
see the
зачитала.
stars.
Возможно ли такое, что вот эта
There is
двойная
also, in
звезда,
addition to the question,
Солнце,
is it
да,
possible
двойник,
that
она
such a
излучает
double star,
невидимым прибором
this twin of the sun, it emits some radiation in the invisible range?
So that we have the simple physics, we have different ranges: the gamma, X-ray, ultraviolet, optics, radio. So we don't have different ranges, and so that in all of those ranges we've seen it, right? If, for example, we would say that there is a new range that is not visible, that we don't have places for that. You can take into account anything like you want to, but like there is a philosophical term, so like the teapot of Russell or something. You either heard it, he made a joke that, for example, it was like you on the orbit you have a teapot with tea. Could you prove that it's that way, or could just disprove it, so that proposingly we have an instrument that has a big meaning, so that it actually absorbs all the X-rays, so that it has this kind of matters or this kind of values. So you have the case where you cannot actually move away from that, as you would mention that, and but it has such a properties. But if you would mention like this kind of energy, the new one, if in the physics or something you have the new cases or something else, but you don't see that, nobody discovered that. So the purpose, you can say whatever you want, but physics goes against all of that.
Спасибо большое. Есть еще
Okay,
вопросы?
got it. Thank you very much. There are more questions.
Сергей, скажите, пожалуйста,
I want
какой
to ask you
объект
another
или взрыв
question.
какого-то
Please
космического
tell us,
объекта, это внутрь,
if we
может
take any
повлиять на
object, space
ядра
object,
планет
an
Солнечной
explosion of
системы или
such an
других
object,
планет, ну,
can it
другой системы?
influence the nuclei of planets, a solar system or another system?
I don't know why is it all connected to the core,
Да, на
but
планете.
just to on the planet, it can actually, if we would face with a planet that would came to us outside of the solar system, or it was the big massive bodies, then it can diverse the core or just break the planet in two. The influences on the core of the planet, it's not supposed to. And so that we need to either rephrase the question or something. I don't see any actual movements or influences.
Yes, probably we'll write down this question and clarify the points and send to you later,
Есть еще один вопрос.
or maybe they will send us later. Another question
Если
is the
объединить
following.
науку во всем мире,
Okay, if we
ученых во
unite
всем мире,
science
то
all
какие
over the world,
перспективы
all
для развития
science
науки
all over the world,
открываются?
what will be the prospects for the science development?
We don't see big perspectives or capacity. If there's like where I'm special, is because the number of good instruments like astronomical tools is actually restricted in the number of people who can at the same time work on them, but the value of those instruments are really high, so the fee for them is really high. So we had Hubble on this orbit, so that they've seen pictures from that. There was an institution to do so, to get the image and everything. So there's many people applied. So the price was $1 million. So that they've been there for 10 years. So that, sorry, 400 millions a year for 10 years. There's 10 billion, and so that also the launch. The instruments are really expensive, and we don't have enough of them for all of us. So that to unite the science, it doesn't get to the moment so that we were able to solve something in a simpler way. There's many groups of peoples in the world, but like if somebody participates there, you start to make articles. But I'm actually frightened by that, where they have 500 co-authors or 1,000 co-authors. I don't understand what in this collective, what is your personal input for that, so that the science happens to be moved to the manufacturing part, so that it's just like a factory. So don't see any future moves of development. Maybe if you have new telescopes built, then in any countries, then something could be achieved actually. But
Спасибо большое. Спасибо, Сергей, за ваши ответы. Очень
Thank you
интересные.
very much. Thank you,
Спасибо
Sergey,
нашим
for your answers.
зрителям,
They're
которые
very
задали
interesting.
такие интересные
We
вопросы.
kindly thank our
Есть
viewers
еще
for asking such interesting questions.
I actually would like to ask one more question. Can I? So I have a question like this. So everything is fractal in the world, and so there are like electrons that are circling around that atom core. So the postulates of Bohr can be used to describe them, but this is not the case of solving this issue. There are some other powers or forces that we don't know yet, that that enables electron not to fall to the atom. So what interests me is about planets. Is everything clear about it? So can just one gravity field make stable, orbits of the planets?
what is known right now, if you were speaking about the Earth and Newton or something, even the Newton's laws so greatly describes everything that the precision is really, or an accuracy is really high. If you were to conduct observation during thousands of years, so that you were observing like in one time, one period, so it actually can happen so that you could have new things that we are not feel right now, but there was the accuracy that we can work right now. Everything will go directly on by the Newton's law. There's no additional things that we would feel. From time to time, people do speak that the space stations and everything, the Voyager, that happens to be outside the solar system, so that it happens to be the lower in speed or whatever the reasons, and the scientific world starts to discuss it, that it happens to be that actually the forces of the gravity, it doesn't happen like in one thing. It's and was the different, for example, equation that it was before. So, but then we found out that actually everything can be explained from the position of the standardized theories. So that actually scientists are really happens to have wide imagination. So we can't go on without the fantasy. No matter how we fantasize, there's supposed to be a stable of ground and how you check it. If you're able to explain everything in a simple way, maybe it's most likely that it's the most precision one. So that there is a term that no matter when the Einstein theories happened and the theory of the Newton doesn't work, for example, for the Mercury, right? That it doesn't move on the orbit that Newton was telling us about. They were trying to input the new planet, and but still it happened to end up with the thing that the Einstein theory explained everything well. And until we will describe it well, it will be the only right one. The new every theory that's supposed to include as the background both the Einstein theory and the Newton theory, and on that level they're supposed to be in the formulas in the way that it was described before. So that so far we don't have any new forces. If you would speak about the atoms, but they're the quantitation theory, it's not built till the end, and so there's new things, new possibilities, and new everything is still present.
Спасибо вам большое, да.
Thank you very much.
I'm also not a specialist there, but still, it's not specifically known, so not everything is
Спасибо
known.
большое. Хотели вас
Thank you very
поблагодарить
much.
за
We
такую
want
интересную
to really
содержательную
thank
беседу.
you for such an
И за то, что вы
interesting,
согласились, за то, что мы
comprehensive,
сегодня встретились.
substantial
И я думаю, что это
conversation
будет
for
таким новым
accepting our
толчком для
invitation.
новых
Thank you
идей,
very much. It
для
will be a new
дальнейшего
impulse
сотрудничества.
for new
И в знак
ideas, for the
благодарности мы хотели
cooperation.
подарить
And
доктор
as a,
физика «АЛЛАТРА».
with our
И книгу
gratitude, we would
«АЛЛАТРА».
like to give
Покажем,
you as a
покажем
present the book
через
АЛЛАТРА
экран, но
and
наши
the
друзья в Москве
primordial
желают
АЛЛАТRA
в
physics
Москве
report.
увидеться,
We'll show them
когда это будет возможно,
by
и
this.
передадут вам
Hope that
наш
our
подарок.
Moscow friends will see you in
Может,
person in Moscow and give you our present.
It was really nice for people who are interested getting together in such a big project, and they spend their time and will to do something for the good around themselves and in the world. And thank you so much to the viewers that went through and listened for such a strange discussions. Thank you so much.
Сергей.
Thank you very much.
Thank you a lot, Sergey. Your answers are really inspiring, and it is so joyful that this meeting has taken place. We are confident that it's not the last meeting, and we surely wish you success in your work, because you're doing a very important job, not just for radio astronomy, but also for every person on Earth, because probably the discoveries which you will make or your colleagues in other fields in radio astronomy, they will open up new horizons and be able to travel to other planets, galaxies, and this will inspire us. We hope that you will have inspiration for making discoveries, and we hope that science will serve peaceful purposes, just like it should.
I think that your input is not lower than ours, so thank you yet again.
Вместе мы совсем справимся.
Together we can do a lot. Together we can cope with everything. Thank you very much. Thank you.
До новых встреч!
See you soon.
Thank you so much.